So the two videos before this have led up to this method, Gaussian and Gauss Jordan elimination. So essentially we're just going to put together what we learned in the last two videos to really work through a problem completely on our own. So again, our purpose, and there's two different ways to go about this. We really focus on reduced row echelon form, which is just what we use for Gauss Jordan elimination. I'm going to show you both of them. So Gaussian elimination, instead of taking 1, 0, 0, 1, it's 1 and then some number 0, 1. And I'll show you the difference between the two. I prefer Gauss Jordan. I think it's just easier. If you're already going to do all of the work for Gaussian, just go one extra step to Gauss Jordan. So let's take a look at an example together. So let's take a look at a full example, and these are not easy, so please don't be hard on yourself if you're like, I have no idea where you're getting any of this. I'm going to try to walk you through it as simply as I can. The first thing I would have to do, of course, is to write this as a system of equations in standard form. So my first guy is okay, just as he is. But my second one, I'd have to do a little bit of work. This is 3x plus 3 equals y plus 8. That's 3x minus y plus 3 equals 8. Subtract the 3. 3x minus y equals 5. So this guy is actually 3x minus y equals 5. And I'm going to erase that work just because I'm going to need all of the room that I can have on this page to show my work. So my original equation is 2, 3, dotted line 7, and 3, negative 1, 5. That's my first matrix. That's the first augmented matrix. Now keep in mind that my goal is to get to 1, 0, 0, 1, and then two numbers. And those two numbers will be my solution. So from here, there's really no one right way to do it. And so what I'm looking for is, I'm going to show you the way that I typically go about it, and you might not like it because I am okay with having fractions in the middle of my work, and if you're not, you might have to take a few more steps so that you don't have to do that, then that's fine. But I'm going to show you the way that I would do it. And typically my first step is that I really want that first number to be a 1. And again, the goal is to get to the 1, 0, 0, 1, which is the identity matrix. And it's however you get there. As long as you're showing your row operations, you're fine. I'm going to show you my method. So my method is to first get a 1 in that first location. So that means, what would I do to get a 1 there? Well, it's a 2 right now. And so if I don't want to change too much, I just want to get a 1 there, I'm just going to divide 2 by 2 to get 1. So basically I'm going to take half of row 1 and make it my new row 1. So row 2 isn't going to change. And row 1 is basically just going to be cut in half. And again, that's going to give me some fractions, and I'm okay with that. Because this is my method, and I'm okay with fractions. So that's 1. What happens to get to 2? Well, my method is to always then, for my second step, get a 0 in that second location. So how do I do that? This one is not going to be as simple as multiplying by something, because if I multiplied by 0, the whole row would be 0, and that would be defeating the purpose. So what I'm going to have to do here is think about, what do I have to multiply by this to make it the opposite of 3? So how do I make 1 into negative 3? I would multiply it by negative 3. And again, why did I want negative 3? Because just like we did with the elimination method last week, I wanted the same number, opposite sign. So negative 3 times row 1 plus row 2 will be my new row 2, because that's the only one I want to change, is just row 2. Which means row 1 gets to stay 1, 3 halves, 7 halves. And row 2 is now, and I'm going to do the mental math, so I'm going to explain to you the mental math, but feel free, if you need to write it out on scratch paper, to do it. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Next, I have negative 3 times 3 halves is negative 9 halves. Negative 9 halves minus 1 is negative 11 halves, because remember this is like negative 2 halves. Oh, hold on, let me do that one again. I think I messed up my sign. Negative 3, that would give me negative 9 halves plus negative 2, yep, no, I did it right. Just wanted to make sure I didn't screw up. So negative 11 halves, and then I have negative 3 times 7 halves, so that's negative 21 halves, plus 5, which is 10 halves, which gives me negative 11 halves. So that's my next row. Typically, my next step then, so what am I going to do next? My next step is to make this into a 1. And so from there, again, row 1 is going to remain the same. And in row 2, my job is to make this into a 1. So just like I did here on this first step, I'm basically going to multiply by the reciprocal, just like I did before. So I multiplied by the reciprocal of 2, which was 1/2. Now I'm going to multiply by the reciprocal, or in this case, yeah, well, the reciprocal, which is negative 2 elevenths. So I'm going to take negative 2 elevenths times row 2 to be my new row 2. So my first row stayed the same. My second row, I'm taking negative 11 halves times negative 2 elevenths, and magically I just get 1. So this is 0, 1, 1. Now I'm going to stop here for a moment because I told you there were two methods. The first is Gaussian, and we haven't even really talked about that yet. If I'm doing Gaussian, I'm done right now. Gaussian elimination uses back substitution. So from the point where I have 1s as the first in each of my rows, and I have a 0 underneath each leading 1, which is what I have, I would then write this as x plus 3 halves y equals 7 halves, and then I would write this one as y equals 1. So basically I turned both of these back into equations, and then I would use back substitution, which means take my y value and substitute it. So I have x plus 3 halves times 1 equals 7 halves. 3 halves times 1 is obviously just 3 halves. I would then subtract 3 halves from each side, which would give me 4 halves, which means my answer is 2. So that's using Gaussian elimination. I don't like Gaussian elimination. I say, if I'm going to do all this work, all these row operations, all it takes with Gauss Jordan is one more row operation. So again, that is where I would stop for Gaussian, and now I'm going to show you Gauss Jordan. So I'm going to erase all of this stuff that I just wrote down, because we don't need any of that business if we're doing Gauss Jordan, which is my favorite. So Gauss Jordan says, go one more step and turn this one into a 0. Oops, so let's take a look at what that's going to look like. I'm going to keep row 2 the same because row 2 is exactly where I want it to be. Remember, my goal is 0, 1, 1, 0, and so I have the, 1, 0, 0, 1. I already have the 0, 1, so I'm good. But now what I want to do is I really want this guy to be a 0. So how do I make 3 halves into a 0? I would have to add negative 3 halves to it. So I'm going to make row 2 times negative 3 halves times row 2 and add it to row 1 to be my new row 1. So I'm going to take negative 3 halves times 0, which is 0, plus 1, which is 1. And that's why it's important for this to be 0, so that 1 doesn't change. Then I'm going to take negative 3 halves times 1, which is negative 3 halves, add it to 3 halves to get 0. Then I'm going to take negative 3 halves times 1 to get negative 3 halves, add it to 7 halves to get 4 halves, which is 2. So then my final answer is 2, 1, which is the same thing I got with Gaussian elimination, but I feel like Gaussian's more work because then I have to turn it back into an equation and then substitute it back in and show all of that work, and here I don't have to do that. So this is my final answer for Gaussian and Gauss Jordan elimination. Here's one for you to try on your own, and in a few minutes I'll go through it with you. In a few moments, not minutes, I'll go through it with you. I'm going to go through this one a little bit faster because I feel like I tried to explain things as best I could in the last one. But go ahead and press pause, try this question, then press play to see how you did. Again, the first thing I need to do is make sure that these are in the proper format. So this is 2x minus y, I'm sorry, negative 2x plus y equals 5. And this guy is already in the right format. And that means my first matrix is negative 2, 1, 5, 1, 3, 15. I'm going to follow the same steps. So my first step is I'm really going to try to make this into a 1. And so let's do that. Let's take my first equation times negative 1/2. So negative 1/2 row 1 is going to be my new row 1. So I'm pretty predictable. I'm just going to do the same steps I did last time, same basic process. So I'm going to do negative 1/2 of negative 2 is 1. Negative 1/2 times 1 is negative 1/2. Negative 1/2 times 5 is negative 5 halves. Row 2 remains exactly the same. My next step is that I really want to get this guy to be a 0. So that's what I'm going to do next. Oh, I keep forgetting to switch back to pen. So to get that guy to a 0, lucky me, I already have a 1 here. So I should just be able to take row 1 minus row 2 to be my new row 2, because 1 minus 1 is 0. So that is what I'm going to do. So I'm going to get row 1 gets to be exactly the same as it was before. Row 2, 1 minus 1 is 0. Negative 1/2 minus 3 is negative 3.5, or negative 7 halves. Negative 5 halves minus 15. So again, whenever you need to, you just show some extra work off to the side on scratch paper. That's negative 35 halves. Okay, so that's where we are so far. Looks like I lost my highlighting earlier when I did my division. So now what's going to happen? Now I really want to turn this guy into a 1. So that's my next step, is I'm going to figure out how do I get to this guy to be a 1. That's what I want. So how would I get it to be a 1? I would take it times the reciprocal. Negative 2/7 times row 2 is my new row 2. So row 1's the same. Row 2, I'm taking negative 2/7 times 0. That one's easy. Negative 2/7 times negative 7 halves turns into 1, which is obviously why I did it. Negative 35 halves times negative 2/7. These guys reduce, and I get positive 5. So that's where I am so far. Remember, I could stop right here and write my two equations and do back substitution. I'm not even going to do that because honestly, it seems like a waste of time. But feel free, if you really like that other way, hey, to each their own, right? Now my last step is I want to turn that into a 0, which I think is less work than using Gaussian elimination. So I'm going to, whoa, not marker, let's go back to pen. So I want to take my first row times negative 2. because I want that to be a positive 1. So negative 2 row 1 is going to be my new row 1. So row 2, exactly the same. Row 1, oh, I'm wrong. I'm sorry. I got confused for a minute. Woo! Let's back it up. I don't want to do that because then what's going to happen is I'm going to end up with not a 1 here. I want to add something from this row to this row. So I'm just going to take half of row 2 and add it to row 1 to be my new row 1. Sorry about that confusion. So half of 0 is 0 plus 1 is 1. Half of 1 is 1/2 plus negative 1/2 is 0. Half of 5 is 5/2 plus negative 5/2 is 0. So my solution as an ordered pair is 0, 5. Keep in mind, just like last week, you can always do a check by plugging these answers back into these equations to make sure that you're correct.